All right, guys, here we go. All right, question number one. You guys ready? So graphing sine and cosine. Question number one. Find three angles, two positive, one negative, that are coterminal with the given angle, and they give you 10 pi over 9. Look how simple it is. Start with 10 pi over 9. Do you remember what coterminal means? It's the same ray as 10 pi over 9. So where is 10 pi over 9 on the unit circle? Notice that 10 pi over 9, if it were 9 pi over 9, that would be pi. So 10 pi over 9 is just a little bit past the pi. It's something like right there. So if I just do another plus 2 pi, do you guys see this? If I just add 2 pi to that, I'll be back in the same ray. Does that make sense? And there it is. So that's what we did last time. If you remember a long time ago, that's what we did. So we're going to add 2 pi to that. See? Because if I add 2 pi, I'm in the same location. See? Yeah. So I'm adding that 2 pi there, guys. And all I got to do, I just got to get that denominator to be a 9. So I'm going to go times 9 over 9. See? So when I do that, I have this 10 pi over 9 plus 18 pi over 9. What's 10 plus 18? 28 pi over 9. That's going to be my set. I guess that's my first, because they said three angles, two positive, one negative. So then I take the 28 pi over 9, and I'm going to add another 18 pi over 9. Because they say two positive. So if I want another positive, I just add another 2 pi to it. Because I'm still going to be in the same range. Does that make sense? So, why did I write what? Because 18 pi divided by 9 is 2 pi. So every time I do a revolution, I'm still in the same location. You know what I mean? So 28 plus 18, 28, 38, 48, subtract 2, 46. So 46 pi over 9. Cool or not cool? So we got our first two, first and second, and it says one negative. So instead of, I'm going to go back to my original, the 10 pi over 9. And instead of adding 2 pi, what do you think I'm going to do? Subtract 2 pi. So I'm going to turn that 2 pi again into, into 18 pi over 9. There's my 2 pi. And then 10 minus 18, I believe that's negative 8. So there it is, negative 8 pi over 9. So I'm looking for negative 8 pi over 9, 28 pi over 9, and 46 pi over 9. Do you see that? There it is. Oh, I tried to do a happy face. But okay, whatever. All right, how do we feel? All right, second question. Name the quadrant in which the given conditions are satisfied. So here we go. This says sine is negative. Where is sine negative? Remember, sine is the y value. Sine is negative in quadrant 3 and in quadrant 4. That's what it means. This is what sine less than 0, that just means sine is negative. Sine theta is negative. That's what it means. And then it wants to know where tan is negative. Well, tan is negative in quadrant 2 and in quadrant 4. Do you guys see that? So which one has both of them? Quadrant 4. Can we continue? Question 3, you just don't know that you know. We actually skipped some of the notes. That's on me. We should have done it, but I wanted to skip it because of time. But it's over question 3. It's pretty basic. It says, let some point denote the point where the terminal side of an angle theta meets the unit circle. If p is in quadrant 2 and x equals negative 3/5, evaluate the 6 trigonometric functions of theta. Guys, all that means is this. You have here's my x and y axis. Here's the unit circle. And all that means is, from the origin, you go to quadrant 2, you make your reference triangle like so, and that coordinate is a negative 3/5 for the y. And then the hypotenuse or the radius is always 1, so negative 3/5. What do you think the y value is? You can use Pythagorean theorem if you want, but you can probably figure it out just How would I figure it out? I mean, yeah, Pythagorean theorem, right? No? Yeah. It's 4/5. Should be 4/5. Right? 3, 4, 5? No? Okay, I'll show you. Look. A squared plus B squared equals C squared. The C squared is a 1. So I'm going to go negative 3/5 squared plus Y squared, which we don't know, equals 1 squared. I'm going to move this to the right. Y squared equals 1. 1 squared times 1 times 1 is 1. Minus, when I move it to the other side, it turns to a negative. So let's see. 3 squared is 9. 5 squared is 25. So 9 over 25. Child, I need a calculator. I don't know how to do this. You don't need a calculator. Square root. Turn this 1 into 25 over 25. Y equals the square root 25 over 25 minus 9 over 25. Y equals the square root 25 minus 9 is 16 over 25. Laws of exponents, 4 over 5. And because I'm in quadrant 2, it's going to stay positive. So there it is. Y is 4/5. So my coordinate is negative 3/5 comma 4/5. We're going to go slow. Don't worry. Because it's a unit circle, cosine is x, sine is y. So I'm going to look for cosine theta is negative 3/5. Nope. Maybe. Let's see. Maybe. Oh, no. Nope. Maybe and nope. So it's between B and D. Cosine is 4/5. So I would say sine is 4/5. So sine 4/5, sine negative 4/5. It's letter B. And then just verify. Let's see. What would I do? I would probably go cosine sine, and then I would do tan 4 over negative 3. So for tangent, yep, 4 over negative 3. Bless you squared. Cotangent, negative 3 over 4. Cosecant is reciprocal of sine, yeah. Secant is reciprocal of cosine, yeah. So there it is, guys. Did all that make sense? And no yawning. You guys are going to get me yawning, and if you get me yawning, everyone gets an F. Nah, yeah, we won't do that. All right. This one's pretty basic, guys. You don't need a calculator. I don't think you do. Rewrite the following expression in terms of its reference angle, deciding on the appropriate sign, positive or negative. Okay, 154 degrees. What quadrant is that? Yeah, exaggerate quadrant 2. It doesn't have to be perfect. Here's 154. How close are you to 180? That close. Go 180 degrees minus 154. Let's see, 64, 74, what's that, 26 degrees? That's my reference angle. What they want to see, it says rewrite the following expression in terms of its reference angle. Out, maybe. Oh, that's a 36. Out, maybe. So it's between C and E. Look how easy this is. You guys ready? In quadrant 2, is cotangent positive or negative? Yeah, negative, because cotangent is x divided by y. So it has to be this one right here. Because cotangent 26 alone will give you a positive number, but cotangent of 154 we know is negative. Does that make sense? Okay. Yeah, ask me, guys, because I cannot read minds. Are we okay with that? Okay. Go to the next one. Cosecant 5 pi over 3. CSC 5 pi over 3. This is one of our common angles. 5 pi over 3 is in quadrant 4. It's like right 5 pi over 3. Double the denominator, subtract 1. So the reference angle is this guy right here. That reference angle is pi over 3. Either pi over 3 away from 2 pi. Correct? So, out, maybe, out. It's between C and D. Cosecant is the reciprocal of sine. Is sine positive or negative in quadrant 4? Negative. So you have to choose the one that says negative. Because cosecant of pi over 3 is positive, so it needs a negative in the front. Does that make sense, guys? Okay. Yes. All of these, if I were to tell you cosecant of pi over 3, that's a positive number. How do I know that? Because pi over 3 is in quadrant 1. They're all acute angles. So in quadrant 1, everything's positive. But I don't want cosecant of pi over 3. I want cosecant of 5 pi over 3. Well, 5 pi over 3 is in quadrant 4. So if I just type this in the calculator, it's going to give me a positive number. I need to have a negative in the front if I want it to be the same thing as cosecant 5 pi over 3. Does that make sense? Now let me know if it doesn't make sense. For the quadrantal angle pi, give the coordinate of the point where the terminal side of the angle intersects the unit circle. Okay, relax. All that means is, where is pi located at? What's the coordinate of pi? Yeah, is it 0, -1, or is it -1, 0? I heard both answers. Which one is it? Yeah, the x coordinate is negative. -1, 0. So let's look for that. Out, maybe. Out, maybe. It's between C and E. Next, what do they want? Find sine and cosecant of the angle. Okay, well, sine of pi is 0. And let's see, cosecant. CSC of pi. Cosecant is reciprocal of cosecant is reciprocal of sine. 0 does not have a reciprocal, so that's undefined. So look for that. Let's see, sine pi 0, cosecant undefined. There it is. Letter C. Do you see how we did it, guys? Okay. Let's go to the next one. Don't freak out. Don't freak out. Relax. This means this. Sine of some angle equals a -1/2. On the unit circle, sine is going to be a -1/2. Boom, boom. Let's see. Not at pi over 6. Not at undefined. Maybe a negative pi over 6. Nope, nope. Negative pi over 6. Negative pi over 6 is this angle right here. Remember, goes clockwise. Are we okay, guys? Yes. All this means, you see how it says sine -1, -1/2? That means if you were to say equals theta, that means sine some angle equals a -1/2. That's all it means. It's just the inverse of it. Are we? Close the door. Yeah, that just means no one can go to the restroom. Yeah. So I hope. Yeah. All this. Okay. This. So whenever you see arc sine of, I'm just going to use x and y. X equals y. That just means sine y equals x. That's all it means. It's like inverses from algebra 1. So sine of y equals x. So sine of what angle gives me that -1/2? So these are the only two angles. You could have said 7 pi over 6, 11 pi over 6. They didn't say those. Actually, we got to talk about the principal branch, but we don't know enough. We haven't talked about domain of inverse functions. But yeah, it's negative pi over 6. All right, so look at this one. Ready? Check it out, Morales. So you see what this one, what does this mean? This means cosine of what angle equals square root of 3 over 2. Now, we haven't talked about inverse operations or inverse functions just yet, but I think for now, I think we'll be okay. So on the unit circle, what's up? Why don't we put the 1/2? You can. That's just, that's what UH likes to do. UH likes to say 1/2 with a square root of 3 on the side. That's the same thing as square root of 3 over 2. I actually don't like the 1/2 in the front. That's just me though, but it's fine. Not a big deal. What's the angle that will get me a square root of 3 over 2? Yeah, actually this one will also work, but they're talking about the principal branch, so that pi over 6 is in the principal branch. If you get one of these wrong, but you got the right answer, let me know, and I'll give you the credit because we haven't talked about inverse functions yet. Okay, are we still okay? Okay, let's go to the next one. All right, arc tan equals -1. So what this means Arctan equals -1. Tan of some angle equals -1. That's what I meant to say. That's what it means. So on the unit circle, it's either this angle or this angle. This angle here is 3 pi over 4. This one is 7 pi over 4. So let's see. Or do those come out first? Nope, I don't see them. What else could it be? This angle, negative pi over 4. And we look for negative pi over 4, and there it is. Say it again. Well, I haven't talked about the domain of inverse tan. It really has to be an angle between negative pi over 2 and pi over 2, but you guys don't have that experience yet. I'm just trying to think, like, how would you guys do it if you guys were taking this quiz? All this means is where is tan equal to -1? So you know in the unit circle, tan of 3 pi over 4 is -1, and tan of 7 pi, like if I write tan of 3 pi over 4, you would tell me that's -1, right? But do you see a 3 pi over 4 in there? No, then you would probably go tan of 7 pi over 4. That's also -1. Do you see a 7 pi over 4 in there? So then I think you guys would just start going through the motions like, okay, well, I see negative angles. This one right here is negative pi over 4. Oh, look, negative pi over 4 is in there. So in reality, the domain of this inverse for the principal branch is an angle between negative pi over 2 and pi over 2. But we haven't talked about domain for this. So that's why I'm telling you, if you get these wrong, but you have the right angle, because sometimes there will be a second angle that's correct. Let me know, and if it's correct, like quote unquote, if your angle does give you that -1, let me know and I'll count it right. Okay, are we okay, guys? Okay, so like let's say 3 pi over 4 would have been in there. This is still the principal branch, and 3 pi over 4 is not in this domain. But if you would have circled 3 pi over 4, it would have probably counted it wrong. But let me know, and I'll count it right. That makes sense? Okay. Yeah, when we talk about inverse functions of arctan, we'll probably start doing something like this. Arctan of -1 plus pi n. So you'll get that negative pi over 4, and you'll add that pi. So 4 pi over 4. Negative pi plus 4 pi, there's your 3 pi over 4. But we're not there yet, so disregard all that talk, because we're not at that level yet. Okay. Say it again. Yeah, that would also work. Wait, hold on. Yeah, because that would be in quadrant 2. All right, and I think that one was in there. Check it out. It was in there. Okay. Is it possible to get sine to be a square root of 2? No. It's always sine and cosine will always be a number between -1 and 1. It is not possible to have a magnitude larger than 1. So undefined. Cool or not cool, guys? It just means inverse. No. No. Arc, cos, arc sine. It has to be a number between -1 and 1. It can't be larger than 1 because the radius of the unit circle is 1. Plus the ratio opposite over hypotenuse. Hypotenuse is always the longest side. Adjacent over hypotenuse. Hypotenuse is always the longest side. So you have some number divided by some number. It's always going to be magnitude smaller than 1. Does that make sense? Okay. All right, go to the next one, guys. Find the period. So these are pretty basic. I don't think you're going to have any issues. Look how simple this is. This looks like a point of inflection going down, and it starts at 0. So I'm just going to go look for another point of inflection going down. Boom. So the period is pi over 2. That's how long it takes for this to do one cycle. So here's the one cycle. See? That makes sense, guys? Yeah, too simple. All right, let's go to the next one. Find the amplitude. Yeah. The midline seems to be the x-axis. I see a positive 2. I see a negative 2. The amplitude is 2. So those are going to be very straightforward. I don't think you'll have any issues with them. All right, this one here, number 13, find the period. The period is based off of the B. This is my B. So that means a half in the front means a horizontal stretch by a factor of 2. If you don't remember that, it's okay. Remember that to get the B, it's 2 pi divided by period. So that's my B there. So if they want the period, you're going to be doing 2 pi divided by B. So 2 pi divided by half, 2 pi times 2, 4 pi. Keep change flip. We're okay, guys? Yeah, no, ask me. This also means horizontal stretch by a factor of 2. The parent function sine has a period of 2 pi, so multiply 2 pi by 2 as well. Yes, all these are in radians. So 2 pi divided by the b. Find the amplitude. Oh, man. It's just a number in front of the cosine. That's it. See, so you guys are going to love this because it's pretty straightforward. Question 15, find the period. It's a number in front of the x. This is your b. This is not the period, but that's your b. That you use that to find the period. Period is equal to 2 pi divided by, that half pi means pi over 2. Divided by pi over 2. Again, keep change flip. 2 pi times 2 over pi. Pi's cancel out. The period is 4. Are we still okay? Are we still okay? Tell me, Morales, tell me. Ask me. Ask me, guys. Ask me, Ms. Johnson. The other one had a half. So 2 pi divided by half. This one doesn't have a pi inside of it. So 2 pi times 2, that was 4 pi. But this one has a pi in it. So this one is 2 pi divided by pi over 2. Key change flip, the pi's cancel out, and I just got 4. Find the amplitude, another one. What's the amplitude? 7. Too fast. Too fast, too furious. All right, this one will probably trick you guys. Maybe, maybe not. Find the phase shift. Is the phase shift pi to the right? No. They tricked you. You gotta factor out a pi over 3. So here it is. Factor out a pi over 3. You need the x by itself. So if you factor out a pi over 3, let's see. When I multiply, I better just get pi. That means minus 3. There it is. 3 to the right. If I distribute this, there's my pi 3x. The 3's cancel out. There's your pi. So there it is. So it moves 3 to the right. You can't have a coefficient in front of the x. If you want to, because we're trying to do this, right? Let me go ahead and. No. We have, guys, what are you guys talking about? We've been doing this forever. When have there ever been a coefficient in front of the x? Look at that. There's nothing in front of the x. It's a 1. That's how we've been able to figure out the shift. But notice on this one, this is why I told you certain universities do not use our methods. So you see that this has a pi over 3 in front of the x. You're going to have to factor out that pi over 3 to see that shift of your sinusoid. Does that make sense? Yeah, it's just a different textbook, different authors, different. They just write it differently. All right. Find the vertical shift. That's simple. Vertical shift just means how many times it moves up or down. What was my vertical shift? 4 down. All right, see, look. See how they wrote it? A cosine B x minus C. plus D. Different authors, just write them differently. Okay. Give an equation in the form. Okay, guys, don't freak out. Look how simple this may be. We might not even have to look at the whole thing. So I'm looking for the midline. I see a max of 1. I see a min of -3. So 1 plus -3 divided by 2. I see -1. Do you guys see that? So maybe out. It's between A and B. From -1 all the way to 1. What's that amplitude? 2. Letter A. We didn't have to do anything. Well, we didn't have to do much. I don't want to say anything. But do you see how we got it, guys? And notice we have yet to pick up a calculator. Are you guys ready for the next one? All right, so I look at it. I see a max of 3. I see a min of -1. 3 plus -1 divided by 2. So that is going to be a 1. So there's my midline at 1. So out, maybe, out, maybe. It's between B and E. Next, what's the amplitude? 2 again. So it is B. Do you see how we did it? Okay. That's it. And look how fast we did it.